So we're going to talk about the intermediate value theorem. So what is it? We're going to say let little f be a continuous function, but remember, continuity is defined for points. So we'll say it is going to be continuous on the closed interval from a to b. That means at every point on that interval, it is continuous. So it's left continuous at a, it's right continuous at b, and then between a and b, it's continuous the whole way. So no breaks, everything is good on that interval from a to b. Now what do we say next? We say z is any number between f of a and f of b. Okay, so remember f of a and f of b are y values. We pick any number z between those two y values in our graph. Then there is a number c. There may be more than one, but there has to be at least one number c in what? In that interval from a to b. So at least one number c in that interval from a to b, such that f of c equals z. So let me clarify that here on my piece of paper. In the interval from a to b. C is in the interval from a to b, such that f of c has to be z. So one more time. F is continuous, no breaks, no holes, no jumps, no asymptotes. It is continuous. You can draw without lifting your pencil, starting at a f of a to b f of b. If z is any number between f of a and f of b, I can find some number c such that f of c equals that z. So let's come up with an example to demonstrate how that works. So I'm going to take a look at the following function. We'll say, look at f of x equals x squared. Now, x squared is a polynomial. We know that, so let's go ahead and say it. F of x equals x squared. So that's a polynomial, and we know that polynomials are continuous everywhere. So we're going to go ahead and say that. So since f is a polynomial, it is continuous everywhere. So if that's the case, it's certainly continuous on any closed interval that I give it. So for sure, f is continuous on the interval from -1 to 2. So, and again, here is our rule, right? If f is continuous on the closed interval and z is any number between f of a and f of b. So our a here is -1 and our b here is 2. So what am I going to say about that? Well, let's just go ahead and get those values first. F of -1 is -1 squared, which is +1. And f of 2 is 4. So let's visualize this just so we're clear in terms of what we are working with. I have x squared, f of x is x squared, on the interval from -1 to 2. Here's our graph. I can zoom it in a little bit more, I guess. And those endpoints are there, right? They're not holes. So we have -1, 1 is on the graph. And 2, 4 is on the graph. So this is our continuous function. It is a polynomial. Polynomials are continuous everywhere. So it's certainly continuous on this closed interval from -1 to 2. Now, what do I do next? What's the next thing that this requires me to do? I say z is any number between f of a and f of b. So what that means is f of a here is 1, f of b here is 4. I can choose any number in here, any number that I want to choose in here, any number that I think to choose in here. Then I need to be able to find some c that f of c gets sent there. So for the sake of discussion, let me let y equal, excuse me, z equal, I want z to equal 2.5. So I'm just going to do it as a line here. I'm going to make it dotted. right? So it can go up and down. It can move, but I have this value here that gets sent to 2.5. We see that? We're able to go ahead and find that number. If I didn't want to use 2.5, what if I wanted to use 3.1? Is there a C? Sure. Now the C is 1.761. F of C, F of 1.761 is 3.1. What if I choose 1.2? Z is 1.2 in between those two. Do I find a point C that gets sent to 1.2? Sure, 1.095 in the interval from -1 to 2. That's our idea. We pick any number Z between this lowest point and that highest point, or this endpoint and that endpoint. I can find a C in the interval such that F of C equals that number. So let's take a look. So following the procedure, I'm going to say choose a number Z between -1 and 2, or between, excuse me, F of -1 and F of 2. Choose Z between F of -1 and F of 2, which means between 1 and 4, right? Now, this works for anything you choose. I choose 2.5. Okay. The intermediate value theorem, IVT, tells me there must be a point C because it's continuous. Where is the point C? On the interval, in the interval from -1 to 2, such that F of C equals what I chose. Well, F of X is X squared, right? So F of C is C squared. So what I'm going to say is I'm going to say, fine, F of C is 2.5. That means C squared is 2.5, which means C is plus or minus the square root of 2.5. Now, what is that? Let's get an approximation for that. That's kind of important for us to see what that approximation is. I've done it on my calculator here. The square root of 2.5 is 1.581, which should sound familiar. So it's plus or minus 1.581. Now I said you've got to find a C in that interval, right? There must be a point C, make sure we're clear there. Must be a point C in the interval from -1 to 2, such that F of C is 2.5. One of those is in the interval from -1 to 2. That's positive 1.581 is. But the negative 1.581 is not in that interval. So that is not what we get from the intermediate value theorem. This one is. Now, what's one place we can use this? Let's look at an example. We want to describe the zeros of a polynomial. So as we've said, polynomials are always continuous. So I'm going to give you a polynomial. I'm going to say let P of X equals X cubed plus 2X squared minus 5X minus 1. So I'm going to say use the intermediate value theorem to describe the zeros of the polynomial. So we want to start with 1, 0 somewhere. So I want to take a look at what the function looks like. So let's go ahead and go back to Desmos. And we have a polynomial P of X equals X to the third minus or plus 2X squared. X to the third plus 2X squared minus 5X minus 1. Okay, well, let's zoom this out a little bit, or at least let's get more Y. My X isn't bad, but my Y, I need a lot more Y. So let's maybe go from It's here. Let's go from -10 to, can we see it? Oh, I lost it. Oh, I erased the function. That's not good. Let's undo that. There we go. Well, that's not bad. So I have this situation, and I have 1, 2, 3 real zeros. It's a third order polynomial. I could have 3 real zeros. What's happening at -4? What's happening at -3? We see a 0 between there, crisscrosses in between. Well, how do we know that? Can I prove that there is a 0 between -4 and 3? -3, excuse me. So that's my goal. Goal, prove there is a real 0 between -4 and -3. So how am I going to do that? Well, what's P of -4? And what's P of -3? So maybe I'll jump to the graphing calculator to do that. I'm going to put that function in. X cubed plus 2x squared minus 5x minus 1. And again, we're not going to get a real good window. If I go to zoom standard, maybe I can zoom it out from there. Oh, that's not bad, I guess. But again, I want to know what's happening at -4. So I'm going to go to the table. I want to ask, I'm going to clear the table currently. Then I will ask and fill in my own numbers. So what's happening at -4? At -4, the value of the function is -13. So P of -4 is -13. How about P of -3? What is that? P of -3 is 5. Now, what does the intermediate value theorem tell us? Again, we know P is continuous everywhere. So it's certainly continuous on the interval from -4 to -3. Choose any number between -13 and 5. And the obvious one to choose is 0. So choose Z equals 0. Notice that is between -13 and 5. Then there must be a C. Between -4 and 3 on the interval -4 to -3, such that our function P of C equals 0. So C is the 0 of the polynomial. That proves it. That proves that there is a 0 between -4 and -3. Now we can actually find that 0. We can use the 0 finder. We've been using the maximum and minimum finder. Here's the 0 finder on the calculator. Move the cursor a little bit to the left of the 0 that we're interested in. There we go. Notice this algorithm on the calculator is in essence the intermediate value theorem. Left bound, that's A, that's negative. Right bound, that's B. I choose 0 in between, I need to guess. And it gives me a 0 of approximately -3.388. So sure enough, we found a 0 between -4 and -3 that worked. But the reality is we have more zeros, don't we? So I'm going to go back to the graphing calculator and look at the table and see where are the other zeros. So this time I'm going to go to an automatic table. And maybe I'll start at -. 6. F of -6 is a negative number. F of -5 is a negative number. F of -4 is a negative number. But F of -3 now is a positive number. So this tells me there is a 0 between -4 and -3. I choose any number between -13 and 5. I choose 0. I've got to find the c in between that will give us 0. So sure enough, there's a 0 between -13 and -5. What else happens between -1 and 0? You see f of -1 is 5. Excuse me, p of -1 is 5. And p of 0 is -1. So let's look at that. P of -1 is 5. And p of 0 is -1. Choose any number between 5 and -1. So 0 is between 5 and -1. So there is a c in the interval from -1 to 0 such that p of c equals 0. So that's the second 0 that we have. And then where's the third one? You'll notice p of 1 is -3, p of 2 is 5. So with the sign change, p of 1 is -3 and p of 2 is 5. Choose a number between -3 and 5. Again, 0 is between -3 and 5. P is continuous because it's a polynomial. So there is a c between -3 and 5. We call it a 0, such that p of c equals 0. And let's go ahead and find the zeros using the graphing calculator. Let me just show you that we are correct. So here's my graph. We already found this 0 here, the -3.388. What is this one? Second calc, we think it's between -1 and 0. 0 finder. Move the cursor a little bit to the left of where it crosses the x-axis. Enter. A little bit to the right. Enter. Close. Guess. Enter. And I get a 0 of -0.1873. So C is approximately -0.1873. Between -1 and 0, as we said, right? We said it had to be between -1 and 0. We have one, -0.1873. And then also between -3 and 5. So second calc, 0 finder. Move it over a little bit to the left of where it crosses, a little bit to the right of where it crosses, and guess where it crosses. And what do we get? We get 1.5758. Okay, so I made a small mistake. Can we fix it? Do we see the error? I picked 0 between -3 and 5, so there is a C between what? Between 1 and 2. So let's go ahead and fix that typo. Between 1 and 2. That's what that's about. We pick a number between the two y values so that we can find the C between the two x values, such that f of C is there. And sure enough, that is our C. C is 1.5758.